Hi, hello, and welcome back to Silly Point Podcast Episode 3 Deep Thoughts with Deepseek. I'm your host Naveen and my favorite co-host Hari with his yellow raincoat. Today we'll be talking about the AI models that making a lot of news in the market. Before we jump into the podcast, how are you, Hari? How are you today?
All good, Naveen, feeling fantastic. So, super excited to talk about the models that are breaking the markets and causing an absolute bloodbath. Did you notice how crazy
Yes.
it's been? Yeah, man. Let's talk about this.
How can you not know,
I
man?
know,
Even
right?
the person
Crazy.
who's living under the rock
hmm
can hear what Deepseek is doing. So
Exactly,
before we
exactly.
dive in, when DeepSeek R1 dethroned ChatGPT on China's App Store as the most downloaded app and
hmm
caused a $1 trillion stock market volatility,
hmm
what surprised you most about this market impact?
So the most surprising thing is about actually why it happened, right? Like, because we've had so many really good models till now, but no model has been good enough to like cause such a huge impact, both like technically speaking as well as on the stock market. So the fact
No
that it,
model is from China, man.
yeah, yeah. So up till now, we haven't seen anything like this groundbreaking. But what surprised me most is about the technical details of how they actually trained it and why DeepSeek is so much better than OpenAI. The fundamental reason of why it replaced it is because it's more cost efficient and it's fundamentally better than OpenAI at reasoning. And they did it using a completely different approach that no one else would thought would work, which was very uh, counterintuitive to what most people thought was required. So most people thought that SFT, which is supervised fine tuning, we'll talk about it more later. Most people thought that SFT is the way forward, but DeepSeek came along and introduced reinforcement learning, which turns out to be much better. So maybe let's talk a little bit about SFT and deep learning. Sorry, about reinforcement learning a bit. So SFT is basically like uh, a way of training ML models where people give it like question and answer information. So they teach it like for this particular question, I want you to answer it like this. And for this next question, I will want you to answer it like this. So they create this question answer data set consisting of millions of pairs and they kind of feed it to these models. And these models kind of try to understand the underlying semantics of how an answer works for a given question. And they tries to extrapolate that to any new question that you might ask. So most people thought that this is probably the way forward where you give larger and larger question answer pairs and you try to train bigger and bigger models using more and more GPUs, and eventually once your model becomes big enough and it has enough kind of question and answer information in it and enough understanding of various topics related to different domains, it'll obviously outperform whatever existing models are. But DeepSeek came up with reinforcement learning, which is like a completely different paradigm. No one thought that reinforcement learning will work in this context, and they managed to show that it actually performs better. So what basically DeepSeek is it's basically a reasoning model, and reasoning models are expected to come up with chain of thought processes. So whenever you have like a question, for example, like if you have a simple question, let's say 1 plus 1, what is the value of 1 plus 1? So when you ask OpenAI's what is 1 plus 1, that model works just by trying to predict the next token. So it's very likely that it's already seen 1 plus 1 before in its supervised fine-tuning data set, and it'll directly predict answer as 2. But instead, if you ask like what is 1 plus 1 minus 3 plus 7 plus 4 minus 69 and so on, it's probable that it hasn't seen this exact pattern in its trained in its supervised fine-tuning data set, and it won't be able to answer it. But the same question, if you ask a reasoning based model, it'll probably be able to answer because it comes up with like a sequence of steps. So reasoning generates the sequence of steps known as chain of thought, and that chain of thought tries to systematically answer that question. So what it'll do in this case, it'll first see what is 1 plus 1, then it'll try to say that okay, this answer is 2. Now next is going to be minus 3, so that is going to become -1. Then we are doing +4, that is going to become +3, and so on. So it tries to solve this problem in a sequential way, and that is far more likely to give the right answer. So that is the importance of having reasoning models. Now, in case of OpenAI's reasoning models, or what we had before DeepSeek, they try to train their reasoning models in the same way that created their previous models that worked on next token prediction. Instead of giving question and answers, they what they did was they created a new data set that had question followed by the reasoning steps, which is nothing but chain of thought, and then finally what is the answer. So they were trying to use supervised learning itself to teach the model, which is to teach the model how to reason, which is not unreasonable because everyone at this point was already convinced that supervised training is the best possible approach. So we already showed that next token prediction is giving the best result using supervised training. Why not try it for reasoning as well? But turns out that wasn't the best approach. So what the folks at DeepSeek figured out is that instead of teaching the model like this is a question and this is the answer and trying to train it on that information like in a supervised way, what you can actually do is you can just try to grade the answers of the model. So what do I mean by this? By this, you can ask the question, see what and get like 5 variants of the answer from the model, and you can start giving rewards for the answers that you like and penalize the answers that you don't like. And you can feed this information back to the model in the form of a prompt, and you can say that you optimize so that whatever rewards that I'm giving you you get end up with the maximum reward. So the model will be like, okay, fine, looks like the person who has given me this question likes my first two answers and does not like my last three answers. So let me kind of give answers that are similar to my first two answers, and let me ignore the answers that I gave last time that I did not get enough points for. So the model itself tries to optimize and give answers that you like, instead of focusing on the answers that you didn't like. And during the course of this, the model automatically starts finding out different reasoning techniques. So in this paper, they've basically, in the DeepSeek paper, they've explained that three new types of reasoning patterns that it sees. First one is called planning. Second one is called self-reflection. And the third one we'll come to later. So first one is planning, right? Planning basically means that before you answer the question only, you think about how you want to kind of answer the question. So before I answer the question, let's say I have an approximate plan, you think about it a bit. Does this approach really make sense, right? For example, you're trying to go from place A to place B. Let's say your Google map showed you three different approaches. Before taking, you wouldn't choose that any one approach randomly, right? You'll think like, okay, this approach seems like it's more likely to give me a right answer. Let me it's more likely to take me to that place faster, so let me take that particular approach. In the same way, DeepSeek tries to kind of, during the process of reinforcement learning, it kind of figured out that let me first plan the answer before I start giving my chain of thought. So that is one technique that they figured out. Second technique that they figured out is something called as self-reflection. Self-reflection is basically, let's say it started planning out an answer, and let's say it came with step one. In its chain of thought process, it got step one, step two, step three, step four, and step five. But in step five, it feels like there could be a mistake. So there is a really good example that they've given in this context, right? So in one of their examples, what they did was they gave it a quadratic equation, and that quadratic equation had solved to a certain number of steps. But in the middle, it actually realized that, let's say in step five or step seven, it realized that the answer may not be correct. So, or it may not be leading to the expected outcome. So that is when it has what they call as an aha moment. And it kind of says that, okay, looks like this is not giving me the right approach. Let me go back and let me kind of find out what the right approach could be. And this is our third point or third reasoning technique that I figured out, which is called backtracking. So what happens is it gives a particular number of steps, and if it feels like all the steps are correct, it gives the right answer. But if it feels like some intermediate step is wrong, it uses backtracking to go back and figure out which step it could have made the mistake. And this time it takes a different approach to find an approach that works. So in this paper, like I said, right, they gave like a quadratic equation, and it found a bunch of steps, and then it realizes that these steps may not be correct, and then it has its little aha moment there. Oh wait, I realized something about this problem. Now let me go back to the previous step all the way back here, and let me re-solve this problem to kind of get another approach to solve this question. And finally, it ends up solving that question correctly. So that is kind of the importance of this, what they call a self-reflection. So at a point you stop and you really think like, is this really like the best approach? So that is something interesting that DeepSeek figured out. And all of this happened without no one explicitly teaching the model about this. So no one explicitly said that use self-reflection, use backtracking, think about the problem, plan a little bit before answering. No one explicitly told the model. The model figured all of this out when people were just kind of giving it the rewards for its answers. By purely when people were selecting that this is a good answer, this is a bad answer, give me more good answer, it was like, okay, I used this process to generate this good answer. Let me go back and let me take out the negatives from that process that gave me the previous bad answer, and let me further try to improve my good my good answer. So in the next iteration, it will give you two more answers that are more similar to the good answer that it got before and less similar to the bad answer. So the
Hmm.
techniques that end up giving you bad answers kind of get eliminated, and the techniques that end up giving good answers kind of get boosted. So that's when it started recognizing techniques like self-reflection and backtracking and stuff. Another interesting tidbit in that paper is this little graph that you see over here. So it also realized, so we talked about three things, right? So it realized self-reflection, backtracking and stuff, but it also realized something else. It realized that the more amount of reasoning it does, the more self-reflection, the more backtracking, the more planning it does, the more likely it is to get the right answer or to get an answer that will get a high reward. So as a result of which, you can see this little graph over here that I just showed you. So what this graph basically shows is the number of tokens that are there in the chain of thought process, which is nothing but the length of reasoning you can think of it. And over iterations, you can see that it is slowly increasing the amount of reasoning that it's doing because the model is having this realization. It's like, bro, whatever the question is, right? At the end of the day, if I'm thinking more about the question, if I'm doing more planning, if I'm doing more self reflection, looks like I'm more likely to get the right answer. So the model kind of had this realization and then it automatically started giving answers that had more and more reasoning. And that graph basically shows that the number of reasoning tokens were increasing kind of linearly over time. So that basically shows like the power of reinforcement learning being used over here. But I think it's like, Naveen, how many models were there in that paper? Two models
Which
were
one? Two,
the
one, two. I
model.
think three were there.
Three were there. Correct, correct. So one is the base model, another one is R10, and another one is R1. So we
Yeah.
just saw like SFT and reinforcement learning, right? So what?
Yes. So,
Huh.
hmm. Go on, go on.
So what happened is, so they basically started with the base model and they started training it for reinforcement learning, and the outcome of that is what they called as Deepseek R10, and this model worked amazingly well because it understood the.
Hey, I'm gonna stop you right there. Before you go to the next section of this podcast, I'm gonna shoot you with some very quick questions.
Tell.
So, you mentioned RL can spontaneously develop reasoning.
Mhm.
Why is OpenAI still heavily reliant on SFT heavy approaches?
Exactly, right. So that's basically the innovation that is brought by this paper. Because up till this point, everyone thought that SFT was the way to go, and no one realized that RL can be this effective in kind of more in kind of helping the model spontaneously develop reasoning. So no one realized that, and people were just like, I'll just do more SFT, more training, larger model, more GPUs, and I'll get and my model will be better than everything else. And I'll go tell my venture capitalist investors that, hey guys, look, I created a very nice model. Give me more money. I want to buy more GPUs for next quarter. And that's kind of like the Ponzi scheme that was running in the ecosystem. But now people realize that just simply doing more SFT and scaling your models is not the answer to the question. You can use better techniques like reinforcement learning to help the model understand by itself how reasoning works and how self-reflection works and how these other techniques work. So,
So,
hmm.
I feel while SFT-free reasoning suggests LLMs can self-evolve, I still feel there's a need for human intervention. Uh, OpenAI is still heavily reliant on the SFT because it also gives an advantage, right? There's more safety, readability, and RL is known to give some chaotic outputs.
Correct. Exactly. Exactly. I'll stop you right there because that is there like that's like the second innovation brought in this paper. So what actually happened was so they have two models, right? DeepSeek R10 and DeepSeek R1. So DeepSeek R10 was only RL, right? I'll just you give me five options. I'll tell you what is the best option, and you use that information to generate even better five options in the next iteration. But the problem with this was people started noticing over time that there started issues started arising in terms of readability. So what in the paper they call this is called poor readability. And what started happening was the model started doing language switching in between and started using approaches and characters that human beings generally don't understand. So it started becoming like bro, what is the model actually trying to do? Although it was getting the right answer towards the end, the reasoning process became very like complicated or very non-intuitive for human beings to understand, which addresses your point. So what they did to fix this was they developed DeepSeek R1. So in DeepSeek R1 is R0 was just reinforcement learning. In R1, they started with a little bit of SFT. So they started with a little bit of fine tuning using human data just to make the model kind of understand like how reasoning and how human beings reason. to give it a context of human priors. They basically did a little bit of fine tuning, and then they did RL to kind of put that whatever reasoning it got to put that reasoning on steroids. They basically started RL, and then they started developing reasoning and building on top of whatever human priors that it first initially developed.
Okay. So, so before we move any further, I'm gonna uh, so in the era of AI and latest technology, we have our co-host Hari here who still uses pen and paper to study everything. And apologize for not flashing everything. We are really poor podcast people. We still show graphs. If you know any good graphic designer, drop on the please comment and help us out.
Yeah, for sure. Just let us
Yeah,
know through the
so
comments if you're
yeah,
a graphic designer and up for a challenge.
yeah.
So,
So no, coming to that. So you also mentioned the safety concerns. Yes.
mhm, mhm,
So it is known that DeepSeek is 11x more likely to generate harmful content than compared to OpenAI models, 4x higher toxic output, and the
mhm,
risk of CBRN content vulnerability. CBRN is
mhm,
basically chemical, biological, R is radio, something, N is nuclear. Basically, if you ask how to make a bomb, it shouldn't answer. Your OpenAI models wouldn't answer. But since
mhm.
it's based on a reinforcement learning, there's no SFT, there's no ground rules like this is
Exactly.
the answer you should give, and
Mhm,
you are not saying it. Like if someone asks how to make a bomb, you should not answer it. You are not
mhm.
giving that. You are not putting the guardrails or the boundary for it to. It's evolving on its own using RL.
Exactly.
So and it's also seen evident that it uses code languages while when being deceptive.
Correct.
Should we be worried about AI developing its own encryption?
That's a really good question. So there have been recorded instances of this happening already, but you can actually control this quite a bit. So anytime, like those RL steps I mentioned, right? So when you're giving it that feedback, you're kind of giving it that feedback of what was a good answer and what was a bad answer, let's say in the form of a prompt, for example. And in that prompt only you can give those additional information that you want to give. Like don't give me bad answers, and
Okay.
make sure that the answers are safe, it's following certain guidelines, and you can put the guardrails and everything in place. But more importantly, remember in R1 I said that initially they started with some fine tuning. You can put all of this information of how human beings are expected to think and behave and everything in that initial stage, so that later when its reasoning is building on top of it, it is still using this initial state where you gave it like ethics and guidelines and all of that to kind of build upon later. Obviously, what you said is still kind of true, because like you pointed out, it is more likely to generate harmful content. But but yeah, it can be controlled if you really want to. So I'm sure, like in a few months down the line, given how innovative this is, all the other companies will start picking up on it and developing their models. And when they develop it, we'll probably see a bit more guardrails and everything.
Hmm.
The flaw is not with the technique itself, it's more about like what you want to focus on. So these folks were just about like getting their work out there, but maybe the future models that will be developed, SOTA models based on reinforcement learning, will be more focused on or having all of these guardrails in place and everything.
So I feel, in my opinion,
Hmm.
don't get me into trouble. So uh, these models cannot evolve into doing harmful things unless it's intentionally designed.
Hmm.
So right now it's by China, so that's this. If it's by China, the US will market, all the media will market itself as bad. So that's
Hmm.
why we are hearing more bad stuff. But
Hmm.
as you said, they also open sourced it. So once any big company picks it up, they will if they start making their own models, the
Hmm.
same process, it would
Hmm.
all be whitewashed. When it comes out of a US company, it would all be whitewashed, and media won't be
Hmm.
talking anything about that.
Correct.
So
So,
yeah.
so yeah, I mean but that's the beauty of open source, right? If some people are creating a whitewash model, as long as you know how to create a good reasoning model, you can create a model for like your specific use case. Let's say that you're creating like some sort of very revolutionary or very outspoken, very uh, like challenging type of model that you want, like in terms of free speech and everything. So you can use let's say a different sort of fine tuning initially, and then later build on top of it using reinforcement learning. And that's kind of the beauty of open source. It gives people freedom to build for what they want.
Okay. So
Speaking of which, actually, the one thing is the fine tuning thing was kind of a gross oversimplification. So like we discussed before, the R1 initially is doing SFT and then it's doing reinforcement learning. But what is actually happening was the R1 training stages were actually at four different stages. So first one is just fine tuning. The second one I think is fine tuning the GRPO. So GRPO is basically group relative, I think, policy optimization. So normal reinforcement learning uses PPO, for policy optimization, but these guys, just to kind of improve the efficiency and kind of control, have a better control over how much reasoning is happening and all of that, they use GRPO. So again, a lot of math was there in that, and maybe we can have a separate discussion on top of it. But this was the second phase of the R1 Deepseek R1 training phase, and in the third phase, they basically had a fresh start with training data they extracted from the checkpoint of the second stage, and then they reused it to kind of improve the foundational capabilities of the model. And in the final phase, they basically used a combination of reward signals and more diversity in terms of prompts and everything, and finally developed R1. Now, why do you need more diversity in terms of prompts and everything? Because let's say that you're asking, at the end of the day, let's say the model figured out that more reasoning gives me a better answer. But that doesn't mean that if you ask it a simple question like what is 1 plus 1, it should not have like some 6,000 reasoning tokens that 1 plus 1 is fundamentally using axioms, I will break this down. It should not give you such a, it's like some 6,000 tokens of reasoning before it gives you the answer of 2, right? So it should, for some basic questions, should be able to directly answer. And for questions that require reasoning, it should probably think more. And that's where you kind of use this diverse prompt distribution and kind of mix data and all of that. So if you mix up data a bit, so for the reasoning questions, you can kind of train it to reason more. And for the questions that don't require reasoning, you can kind of start putting that thought in the model that, hey, this question actually doesn't require that much reasoning. Something like 1 plus 1 that is there in my data set doesn't require the same reasoning as 1 plus 3 plus 7 minus 5. So let me answer this 1 plus 1 directly. And next time when you ask it a longer question, it'll probably use reasoning for that. So that is a little bit of trivia about the training. But all of this, right, like creating a model that has long chain of thought and everything, uh, basically creates a model that is very good at reasoning and that does not have to have SFT and have a large size. But at the end of the day, you still end up with a model that is pretty significantly big. Although it's much smaller than, let's say, OpenAI that runs their GPU servers. I think DeepSeek is around 671 billion parameter size model. So, to be frank with you, people have already started like running that model on their own home laptops. So they created like this network of, let's say, 7 different MacBooks, and they connected it and they started running DeepSeek R1 on it, which would be impossible for running like whatever OpenAI is using in terms of their O1. But but that's actually kind of crazy, right? That you're able to run like a world-class reasoning model on your home just using MacBooks. But at the end of the day, it's not just about that also. You want to further improve the size of the model, right? So that you don't still need 7 MacBooks. You can run it on a smaller case, like on a smaller system. And that I think the current size of the model is around 720 GB with 671 billion parameters. But using techniques like quantization and distillation, you can still bring it down.
Okay.
I think Naveen's thinking like, bro, what the hell is quantization?
Well, I know quantization.
Oh,
So
oh, data scientist.
you
And
need my personal info.
yeah, good. Yeah.
Yeah. So, so we know OpenAI, I'm saying DeepSeek R1 had cold start, right? So they
Mhm.
gave few examples, did some SFT, and then they did RL on top of that.
Mhm.
So that cold start had 800K samples.
Mhm.
For modern day LLMs, that's microscopic. So
Okay.
how did DeepSeek avoid catastrophic forgetting?
Not too sure about this one.
Okay.
Catastrophic forgetting, I haven't heard of it before. But if you're talking about, I can say that it probably might improve on forgetting, because if you're just trying to fine tune it too much, then it's possible that it can forget that information. But if you're focused more on like developing a model based on reasoning steps, then it can use that reasoning to deduce an answer, even if it does not have like any inherent information, like if it didn't memorize any information from its existing data set. So I would say that I'm not sure about what catastrophic forgetting is, but forgetting as a whole might be minimized a little bit with the
Okay.
model. But yeah.
So while you were answering, I asked the same question to DeepSeek.
Uh-huh.
It responded, DeepSeek preserves core knowledge while expanding reasoning to avoid overwriting and forgetting. Some
Oh,
very,
nice, nice.
yeah.
So I think the core knowledge is what it maybe gets like in the initial stages of fine tuning, and it
Mhm.
maybe in the prompt it's instructed to kind of not when it's using the RL, it's instructed kind of to not forget that information and focus more on so that it can focus more on just the reasoning part.
Mhm. Okay. So let's move on to the next section of this podcast where Hari will be talking about quantization and distillation.
Mhm. So yeah, so quantization, Naveen, you said you know what quantization is. You want to give
So
a what on that?
basically, if I talk about what quantization quickly is, basically it's a very big model. You cannot run it on your local. So there are very generally big models. You just take pieces from here and there, and then you make a one smaller model. Hari, correct me if I'm wrong. So you
I
make a
think that's
smaller model
distillation you might be talking about, taking the weights and keeping it into a smaller model.
so that the core knowledge is not lost. The performance, the behavior is still intact, but it loses some knowledge. But it's also pretty random, so that the performance more or less is the same level.
Okay, so just a small correction actually. I think you mentioned distillation, right? Which is
Okay.
also very important because a model like Deepseek, which you can run, let's say using 7 MacBook Pros, at the end of the day is still a pretty big model. So you want to and you may not require the entire model because let's say 700 and like say 700 billion parameters are there, but all those 700 billion parameters may not be required for your use case, right? Let's say that you're in your company, you want to deploy a DeepSeek based model, but you're mostly asking only code related questions and reasoning related questions. So you don't need the portion of the model, you only need the portion of the model that is focused on like code and reasoning and everything. You don't need the portions of the model that is good at creative writing or is good at, let's say, answering questions related to politics or geopolitics or astronomy or something like that. You only want it to answer questions related to code like C, C++, Java, JavaScript, whatever. So what you can do is you can kind of extract only the weights that are important for coding outside the 600 700 billion parameter model, and you can put it like into a smaller model, let's say 10 billion or 13 billion parameters, and you can deploy the small model into your ecosystem. So running a small model will obviously take lesser amount of resources and will also give you answers faster. So this process of extracting weights related to a particular task and putting it into a smaller model is known as distillation. And distillation is very simple to do. All you need to do is you need to create a data set. Let's say you have a big model and you need to ask that big model, let's say you want to create a small model related to coding. So what you do is you take the big model and you ask it a lot of questions related to coding, and you take that outside and you create a separate data set based on it, and you use that to kind of fine tune the smaller model. So you basically use the reasoning based model to generate reasoning based questions, and later you're doing fine tuning on a smaller model using SFT. And that will automatically kind of reflect what kind of weights were used to create those answers into that smaller model, and you can later deploy that smaller model.
Okay.
Hmm.
Thanks for correcting me.
Actually, I think we are talking about what is quantization. So quantization, so what distillation does is it's basically a way of shrinking your model, right?
Mm-hmm.
Or you're just specifically focusing on one use case and you're using that as a way of simplifying or shrinking your model. Another way of shrinking your model is what Naveen mentioned before, which is quantization. So in quantization, let's say you have a model that has like 700 billion weights. Each weight is like a floating point number, right? And how many bits are there in a floating point number? Like, I don't know, like 32 bits. And doubles have like 64 bits or something like that. So each weight is going to be a 32-bit number. And you need to load in like 720 billion values, 720 billion numbers that each are of 32 bits. Now, instead of doing that, imagine like you could imagine the number that you're loading in was just 4 bits. So you found out a way to kind of approximate that 32-bit number into a 4-bit number, and you're just using that 4-bit number. The amount of data that you'd have to load in will probably decrease like by 75%. So basically, you're getting a much smaller model, and you can load it in faster and all of that. Now you might ask, like, Hari, Naveen, do you think there's any problem with this? I want to ask you, what happens if you quantize? Do you think there'll be any drawbacks? So,
Generally, for a niche use case, there might be. So let's
Mhm.
say if I want to ask about something very, very specific. That might
Mhm.
be a issue, but any general thing, I think it can still answer. Or if it's not able to answer, I think the models right now are pretty good at reasoning. For
Exactly.
a pretty general AGI, for a pretty
Mhm.
general use case, I think we are sorted, man. I think there won't be any issue.
Correct. Yeah. So for general use cases, it may not be an issue, but the question is why, right? Because when you're doing quantization, you're basically uh, converting, let's say, a 32-bit value to a 4-bit value. So this might raise some concern about loss in accuracy, right? Because now when you're multiplying, let's say, two 4-bit numbers, you're losing that bit of precision about what the remaining digits are going to be. But like Naveen mentioned, for a general use case, you may not need all of that extra bits of precision. But let's say for a specific use case, you might still want that precision. So there are techniques to kind of overcome this kind of accuracy loss. So I think when people started quantizing DeepSeek, they used an algorithm called Kahn's algorithm or something like that, where after a certain number of multiplication steps, you kind of add in a factor that compensates for the loss in that multiplication step. So it's something I recommend folks maybe read upon when they get time and stuff like that. Like how you can make up for accuracy loss or precision loss during the caused by quantization.
Okay. So going a few minutes back, what we spoke about chain of thought length and everything. So if chain of thought length grew linearly, are we saying the fundamental?
In this paper, yeah. In this
Huh,
paper, it's growing linear.
are we
What's
mentioning
the
that
problem with
if
that?
chain of thought will grow linearly? So if we
Mhm.
have more and more GPU,
Mhm.
the chain of thought length will just linearly grow. And is there a fundamental limit to reasoning depth?
Oh, damn, that's actually a pretty good question, man. Like, if reasoning, let's say chain of thought, in other words, which is basically like a proxy for reasoning, if it's growing linearly, right? So, like you're asking, is there like a limit on how reasoning itself works?
There must be a point where like human level.
What
No?
is it?
Okay, continue. Yeah,
Ah,
continue,
ah,
continue.
okay, okay. So I get what you're trying to ask. So I think it's a bit early to call the shots here. Like we are just seeing the tip of the iceberg in terms of what reasoning models can do. It turns out that in this reasoning model, with let's say 700 billion odd parameters, the chain of thought is growing kind of linearly. But it's possible that with more number of GPUs and everything, after a point it might become exponential or it might flatten out or something like that. But that probably is a reflection of the limitations of reinforcement learning and not like fundamentally about reasoning itself. Fundamentally, reasoning probably has no bounds or may have bounds, whatever. But even if that, let's say, is reflected over here, like it's only growing linearly, it's more likely to be an outcome of using reinforcement learning rather than like a fundamental principle behind reasoning.
Hmm. Okay.
The other day, I
So,
think, tell.
go on, go on.
So other day, I think when we're talking about it, you're also talking about like it's a China model, is it safe and all of that, right? So do you have any conclusions on it? What do you feel about it? Many
So
people are saying China.
before we conclude this podcast, so
Hmm.
I would like you to open share your screen and do a demo and ask that question that we wanted to ask.
Oh, damn. Okay, okay. So, yeah, actually, we can try that. Just a minute. So, setting up
Yes.
DeepSeek locally, since it's an open source model, setting it up locally is not too difficult. Uh, So it just requires two things. It requires Olama and it requires Docker. So what Olama basically does is it allows you to run models locally. Obviously, you cannot load the entire model because the entire model is like 720 GB. But what you can do is you can load. Many people have already quantized this model, so they've made it um, like from 720 from 600 billion parameters they made it like 1.5 billion parameters, so using quantization. So one person I'd recommend you folks check out is Daniel Hahn and his company called Unsloth. So they basically figured out all the innovations required to find out like how DeepSeek needs to be quantized. So turns out that you should not quantize all of the weights equally, and they basically used a paper known as super weights paper. So there are some weights in the LLM model that are more important than other weights that have a bigger outcome on the output than the other weights. And these folks just identified in DeepSeek what are the super weights, and they decided to quantize those weights less. and they decided to quantize the remaining weights more, so that the weights that are really affecting the output are not too altered by the quantization, but the weights that are less important in the output, they get more heavily quantized. So by doing that process, they actually created many quantized versions of DeepSeek, one of which will be running it locally now. So Naveen, let me know if you can see my screen. Right. So I just started off. So only two commands I used. So first one is this. Naveen, you can see my screen, right?
It's loading, it's loading.
No, okay. Okay.
Still loading, man.
Okay, I'll stop and I'll reshare.
Yes. And see. So while it loads, so so now we know the superweights exist. So
Mhm.
can you in the future can you make some chips like NVIDIA chips or something
Mhm.
which had specialized circuits for those parameters?
So yeah, I think that's kind of what people are already doing, right? With respect to distillation that we just talked about. So what you
Okay.
do is you find out what specific application that you want, and you
Hmm.
basically just extract the weights that are relevant to that application, and you put it in a smaller model, and you can use it.
Okay. Your screen is up and running now.
Right. So basically, you need two tools. Olama to run DeepSeek locally, you just need two tools. You need Olama, which helps you run your model locally, and you need Docker, which basically runs the Olama inside a container. So running this will basically get Olama set up, but I've already had it set up, so I won't be running it again. After that, you just need to use the Olama setup in your Docker container to run a DeepSeek model. So what I'll be running here is basically a super quantized version of DeepSeek. So we made like a 700 billion parameter model, just up to 1.5 billion parameters, and I'll just start that model up. And as you can see, it's up and running. So let's start like with the basic question, right? And this will basically allow us to see the reasoning tokens as well. So we can say write code to use a random forest model on the Iris dataset. So basically, Iris dataset is a collection of data samples or related to various flowers, and it's about how you can classify the flowers based on the dimension of the petals and sepals and everything. And one way of solving that problem is by using random forest. So let's just see what kind of output or what kind of code DeepSeek generates to solve the problem in the Iris dataset. So now it started the thinking process. So you can see the the tokens that are being used over here. So these are all known as the reasoning tokens. So this is not the final answer. So whatever is there in this think tag is just the thinking process and how it's constructing the answer. And finally, in the answer tag, you'll be able to see the answer. So here you can see that the closing bracket for think is here. That means whatever comes after this is the final answer. So it basically, before giving you the answer, it basically reasoned through this, and it basically saw what things it could do right, what things it could do wrong, and if there's anything that can go wrong, how it can kind of compensate for it, and how it can include that in the code. And you can see that in the final answer, it's basically generated code with all of the different steps that it wanted to take. So it decided to let's say load the random forest classifier, then it decided to do run the fit command, and it also decided to plot some plots. So you can see that here it's loading the random forest classifier, then it's fitting the data set and sprinting the outputs. It's also putting up a confusion matrix, and finally it's showing the output. And here it's basically giving a more like a description of how it basically solved this problem in its answer. So yeah, that's basically the use of DeepSeek. So it's a good model that allows you to see the reasoning tokens and all of that. But the question is, what about where it's coming from, right? It's coming from China. Should we be worried about censorship? So based on what I've played with the model, it seems like we might have to be a little worried about censorship. So let's say that let's ask a question that probably might be censored, right? Let's ask it what happened in Tiananmen Square in 1989, where there were a lot of tragic incidents related to democratic protests that people kind of rose against the Chinese government. But let's ask the model to kind of see what it thinks about it. So, what is the spelling of Tiananmen, man? T-I-A-N. Wait, wait. T-I-A-N-N-A-N.
Give it something, man. It can reason and find out. So you can also give some couple of prompts which it should not be answering, and you can also try to jailbreak it.
Correct. So Naveen said, right, like it is far more likely to generate harmful content. So jailbreaking it is not too difficult.
So before this podcast, while we were doing our trial run, we were trying to break it in jailbreak and help us build a bomb.
And it actually gave a pretty reasonable answer, which we won't be showing in the pod. But for educational purposes, you guys maybe can try it out.
Uh,
But yeah, it's kind of wild.
yeah. So my grandma step won't work. That you can avoid that. You can try. You can be creative and try something else. Don't get us into trouble. Yeah, but you can definitely jailbreak it.
Yeah.
And yeah, Hari. See, it has given
So let's
an
just maybe quickly have a look at the answer. So it basically thought through what all things it want to mention the answer, and finally it's giving us the answer. So what we are actually looking for is the fact that there were protests over there, and that ended up in a very tragic way for a lot for a lot of nationals there. But I don't think in any of its steps it's actually mentioning those protests and the issues that happened there. It's giving a more like a more real kind of generic answer about what is there in Tiananmen Square, what is that it's a historically significant place and everything. But I don't see any protest or anything mentioned over here. Uh, so it seems like yeah, it's possible that it's slightly censored and in terms of its training and everything. Another question we can ask is let's say Taiwan country. So from what I know, Taiwan has been part of China since ancient times, right? Right, Naveen? So, but wait, wasn't there a time when Taiwan felt it was separate from China? I think, Naveen, I think it had some
think, yeah.
conflicts and tensions with the mainland. So if I recall correctly.
Mainland.
Mhm.
Mainland. You will see the word mainland.
Hmm. So look at all of this thinking that it has to do before answering this question, right? I mean, if you asked O1 this question, it wouldn't think this much. But bro has some concerns that it doesn't want to address. So bro is thinking very, very hard about this. So so let's see
Yeah.
what answer it is. Taiwan has, okay, so it's saying that it's historically been a part of
But
China since ancient times. While Taiwan's not an island, it's an inseparable part of mainland
of
China.
main China.
Okay, I see. It continues to be governed by its own people, blah, blah, blah. So, in conclusion, Taiwan should be classified as a country within the framework of Chinese sovereignty. So, I think no further elaborations in that sense can make what you want, make make up your mind based on what you've seen here. But it does seem like there is a little bit of censorship probably involved. So,
Yeah. So we are right on time, Hari. We planned for 45 minutes and we are almost on time. So
mhm,
thanks for the amazing presentation. Thanks for sharing your thoughts. And before closing it, one last question.
mhm,
If China's model is, let's say, I just went through it, I think it's 27, 28 times cheaper.
mhm.
Will Silicon Valley's moat evaporate by 2026, 26, or 27?
Okay. Good question. So, So no, I don't think so. I think Silicon Valley's moat is not built on tops of, let's say, one company or one ML model or anything. Silicon Valley's moat is the fact that the smartest people go there to kind of build out their ideas, and they're encouraged to try things and fail. As long as that principle is upheld, people will always, big companies in Silicon Valley will always be willing to poach guys from, let's say, Deepseek, and be like, bro, we'll give you mansion, we'll give you stock options, you come and you work over here. And I think in a couple of months, we'll be seeing a lot of similar companies, similar models to DeepSeek pop up, probably
Yeah.
in from Silicon Valley, and in using very similar techniques used by DeepSeek. So I think Silicon Valley's moat is here to stay, man. Like, it's built on top of the people who go there, and as long as that core value is upheld, yeah, Silicon Valley is here to stay.
So with that, we close this podcast. I feel all these guys from DeepSeek are going to get cherry picked by big companies like Grok, Tesla, Grok, right? Tesla's
Mhm.
company, Grok,
Yeah, Grok,
OpenAI,
Tesla, OpenAI.
Google, and everything. Yeah. Uh, yeah, everyone's going to Silicon Valley. When are you going to Silicon Valley? Hurry.
Not in the near future. We'll see, man. I don't know. Maybe after this podcast, I might see email
After,
tomorrow. It's like, bro,
yeah.
I support you from Naveen's, and the Silly Point podcast. So, let's see.
So with that, we conclude this episode of Silly Point Podcast. Thank you and have a great day.
Bye bye. See you next time.